Hi there, and welcome to some math help. This is going to be Math 8, Unit 5, Lesson 1, and this is some homework help from your homework packet from Clovis Unified. So as always, I'm not going to do all the problems here. I'm going to do some that are a sample of what you have in class. And generally speaking, the first problem is one that I typically won't do because it's part of your cool down. Just kind of see what you got out of your lesson. But I might change some numbers here and there to make it something close to what you need to do. So for the first one, let's take a look here. We have, so fill in a table for each input-output rule. And on the homework it says you're putting in a 4 into this little machine here, and you're coming out with a 3. And the way you go from a 4 to a 3 is you divide by 2 and then add 1. So if you think about 4 and you're dividing it by 2, 4 divided by 2 is 2. And then when you add 1 to that one, you end up with 3. So you can see how you go from a 4 to a 3. And what they want you to do here then is to use these numbers as your input and then make sure you put them in and use the same rule there as well. Okay, so that's what you want to do there. I'm going to let you do that one on your own. I'll look at this one over here though real quick where it says multiply by -3 and subtract by 1. So let's say we put our first number in 0. Okay, if we were to take 0 and multiply 0 by a -3, 0 times -3 is going to be equal to 0. The next thing it says to do is subtract 1. So 0 minus 1 actually ends up for us becomes equal to -1. Okay, so that's the rule there. So I put a 0 in, I end up with a -1 on my input and my output over here. We want to do the same thing with a 6. So I take a 6, and the first thing it wants me to do is multiply by -3. 6 times -3 gets you to -18. We're going to subtract 1, so -18 minus 1 more becomes -19. When we take a -5, we multiply it also by -3. A negative times a negative becomes a positive, so I know I'm going to have a positive solution here, and 5 times 3 is 15. So I have 15 for the first part of the rule. The second part of the rule says subtract 1, so we do 15 minus 1. And 15 minus 1 is 14. And our last one over here, we have 33, and we're going to multiply that again by -33. A positive times a negative gives you a negative answer, and 3 times 33 is 99. So we have -99, and we'll subtract 1 more. And so when I have -99 and another -1, that combines to make a total of -100. Okay, so that's how you do that one right there. Let's look at a couple of the next ones here. Here we have some equations where we're going to solve for x. That's the goal there. Again, it says, as a hint, only one of these is an integer. That means only one of them is going to be a whole number. So the rest are going to be some sort of fraction answer there, so keep that in mind. I'm going to go ahead and solve for you and work out for you number 2, and then I'm going to do number 3. The reason if I'm not going to do 4 is very similar to 2. They both have a fraction, so I'll let you do that on your own. So the first thing we have to do number 2 is we want to distribute the -2/5 into each part of what's within inside the parentheses. So right here we're going to do a -2/5 times 5x, right? I'm going to multiply those two things together, and then I'm going to do a -2, so a -2/5, and I'm going to multiply that by a -15, and that combined is going to be equal to 10. Okay, so you don't have to write it out this way. I just wanted to show the two different things we're going to do. We're going to be multiplying that together right here, and then we're multiplying that together right there. So when I have -2/5 times 5, this is like 5/1, and I can reduce the 5's to be 1's there. So -2 times 1 is simply -2, and I still have an x, so don't forget about that x. Keep it connected. Here, this is -15/1, and I can reduce 5, and it goes in there -3 times, so keep the negative there. So now I have a -2 times a -3, which ends up being a +6, and it's still equal to 10. So in distributing the -2/5, you should come up with -2 plus 6. And we can see there how this is true. This is a negative times a positive, so our first term will be negative. And a negative times a negative, our second term should be positive, and it is. Now I want to go ahead and solve for x, and so I will subtract 6 from both sides here. So that cancels out. So we have a -2x equals 10 minus 6 is 4. And from here, we'll divide both sides by -2 so that that cancels out, leaving us with x equal to 4 divided by -2. 4 divided by 2 is 2, and a positive divided by a negative is a negative number. So that's what we get for number 2. And again, it told us that only one of these will be an integer, and that looks like it so far. So if I get another integer, I did something wrong somewhere. Okay, let's look at number 3. First thing we're going to do is distribute this 3 throughout. So -3 times a positive 10 ends up being a -30x. Don't forget the x. -3 times -8 becomes a positive 24, and it's still all equal to 15. We're going to keep the x by itself, so let's subtract 24 from both sides. So we're left with -30x, don't forget that, equals 15 minus 24. Okay, so I have a difference here happening. I have -24 and positive 15. This is a larger absolute value than that one, so my answer is going to be negative. I'm going to have more of these left. And when we compare here, what's the difference between those two there? We're going to say it's about 9 in our case here. So we're going to say 9. So we could think of it this way. If you're not sure, you could think about, well, can you do 24 minus 15? If we change kind of the signs around a little bit, sure. And you would borrow, and 14 minus 5 is 9. And we can, okay, the difference there is 9. But this has a greater absolute value, so we're going to say keep it a negative sign there. Let's divide both sides by -30 in order to get the x by itself. So x becomes equal to 9 over 30. And we're going to say positive because the negative divided by a negative, so we can write this as 9 over 30, which can reduce, and when we reduce that down, 3 goes into here 3 times, and 3 goes into here 10 times. So we'd say x equals 3/10 if you want to write it as a fraction. If you want to write it a decimal, you could write it out as 0.3 because that is also 3/10 there. All right. Again, not going to do 4, let you do that one on your own. Okay, but so far we can see we have one integer and one fraction. So that would mean so far, if this is all right, this should not be a whole number when you do it. Okay, so good luck on that one there. Okay, and finally we have solving systems equations, and we have 2 of them right here. Okay, and so let's take a look here. Let's solve one of these together. So what we want to do is we're going to look at, we can do a substitution method. Okay, which means if y equals x plus 6, we can take this y value and plug it in the place of that one, substituting those two things. So we set up a new equation that says x plus 6 equals 3x plus 2. Now I'm going to subtract x from here, subtract x from there. While I'm doing that, I can also subtract 2 from here and subtract 2 from there. That's going to eliminate the x's here, eliminate the 2's there. 6 minus 2 is 4. And 3 minus 1x is going to be 2x. And so now we divide both sides by 2 to get the x by itself. 4 divided by 2 is 2. So we know our x value is equal to 2. So with this value, we're going to go ahead and plug that into an equation. Let's use that one. It seems to be the easiest. So y equals, we see the equation is x plus 6. So instead of saying x, we're going to go ahead and say 2. We're going to use this value right there. So y equals 2 plus 6, which is 8. So now we have a value for x and a value for y. And because we're talking about a solution for the systems of equations here, we would write it out as 2, 8 for our solution. Okay, so that's it for number 5. I'm going to let you solve number 6, but I'll give you a hint here. It's not going to work out nicely, okay? Doesn't mean there's not an answer for you, but the answer is not a traditional answer. That's it for today. We will see you next time.